Hello dear students, today Maths 2 chapter number 2 miscellaneous exercise 2 sequences and series. See question number 9th. Find the nth term of the sequence 0.6, 0.66, 0.666, 0.6666 and so on. So we have to find here nth term, that is Tn, and the given sequence is 0.6, 0.66, 0.666, 0.4 times 6 and so on. So how will you find nth term of the given sequence? It is very interesting question, very interesting question you can say. So now see the solution. The given sequence is 0.6, 0.66, 0.666, 0.4 times 6 and so on. So here we see that first term is a 0.6 and second term is 0.66. Third term is 0.666 here. So here 0.666 and fourth term is 0.4 times 6. So if we write these terms separately, so what will happen? See this one here. T1 means first term of the given sequence. This one you can check here. It is 0.6. After that, we observe here 0.66 is the second term, that is T2, and T2 becomes 0.66 and 0.66 can be written in the sum of two decimal numbers as 0.6 plus 0.06. See once again, 0.66 is equal to the sum of two decimal numbers as 0.6 plus 0.06. And third term of the given sequence is T3. Let it be T3. So T3 is 0.666 here and it can be written as the sum of the three decimal numbers as 0.6 plus 0.06 plus 0.006. Similarly, fourth term of the given sequence is T4 equals 0.6666 is equal to the sum of 0.6 plus 0.06 plus 0.006 plus 0.0006. If we write like this, so we get Tn as 0.6 plus 0.06 plus 0.006 plus 0.0006 plus and so on up to n times. So dear student, you can check once again T1 equal to 0.6, T2 equal to 0.6 plus 0.06 and T3 equal to 0.6 plus 0.06 plus 0.006 and T4 equal to 0.06 plus 0.06 plus 0.006 plus 0.006 and so on. Here T5, T6, T7, T8, T9, T10 and so on continuously. If we write up to n terms, means Tn becomes 0.6 plus 0.06 plus 0.006 plus 0.0006 plus and so on up to n terms or n times you can say. So what are these? We see that these terms are in GP. So we write here they are in geometric progression, that is in GP. How will you know they are in GP? Check once again. Your first term 0.6 and second 0.06. So we need to find common ratio R. We need to find common ratio R. R equals 0.06 divided by 0.6. As you know very well, R equal to T2 upon T1. R equals T2 upon T1 and it is equal to 0.1. And you know very well 0.1 is less than 1. Now you know which formula is applicable for the sum of all these terms. It is Tn, but Tn is the sum of a geometric sequence where a equal to 0.6 and its common ratio r equal to 0.1, which is less than 1. So we should apply the formula for Sn equal to a multiplied by 1 minus r raised to n upon 1 minus r, where r is less than 1. This is the formula for sum of n terms of a GP, that is geometric progressions. Now using this formula, we get Tn equal to a, that is 0.6 into 1 minus r raised to n, that is 0.1 raised to n, divided by 1 minus r, that is 1 minus 0.1. See once again. So Tn becomes sum of all the terms which are in GP up to n times. So here it is 0.6 into 1 minus 0.1 to the power n entire upon 1 minus 0.1. Now this can be written as 0.6 multiplied by 1 minus, here 0.1 is 1 by 10 whole raised to n, because 0.1 is 1 by 10 whole raised to n, as it is entire upon 1 minus 0.1, it becomes 0.9. Now you can say 0.6 upon 0.9. See these two terms only seriously. 0.6 upon 0.9 becomes 6 upon 9, and its simplest form is 2 by 3. It goes by, both goes by 3, so 3 to the 6 and 3 3 the 9, so we get here 2 by 3. And in the bracket here 1 minus, here 1 raised to n is 1, but 10 to the power n is same, 10 to the power n. Therefore Tn is equal to 2 by 3 into 1 minus 1 upon 10 raised to n. So this is the answer for question number 9, which gives nth term of the given sequence. See once again, your question is 0.6, 0.66, 0.666, 0.4 times 6 and so on. It is a sequence, neither in GP nor in AP nor in HP. But if we take each term separately, so T1 is this, T2 is this, T3 is this, T4 is this, as explained already, continuously we get Tn equal to 0.6 plus 0.06 plus 0.006 plus 0.0006 plus and so on up to n times. And this nth term of the given sequence means it is first, second, third, fourth, fifth, sixth, seventh, eighth and so on up to nth term. Here it is and so on dot dot dot, and it is equal sign here. So we get Tn is the sum of the sequence this. Okay, it is not sum of all terms of the given sequence. No, it is wrong. It is the sum of the nth term only. Sum of the nth term 0.6666666 up to n times. So that term can be written as in the form of 2 by 3 1 minus 1 upon 10 to the power n. If we write the value of n equal to 1, n equal to 2, n equal to 3, n equal to 4 and so on, so we get these terms again. They will be repeated. So this is the nth term of the given sequence. So Tn equal to 2 by 3 multiplied by 1 minus 1 upon 10 to the power n. This is the final answer for question number 9. Now see question number 10. Your next question is related to summation, that is sigma notation. Find summation r equal to 1 to n 5r square plus 4r minus 3. This is the question related to summation. And you know summation formula very well. If you don't know, so don't worry. Click on the link which is given in the description box of the same video. You will get a formula list immediately, and on the last page, see there are 5 formulae which are related to summation. So now see question number 10. Find summation r equal to 1 to n 5r square plus 4r minus 3. Now this question is related to sigma notation formula which is given in the formula list, and this list is also given in the description box of the same video. You should click on that link. You will get formula list. Now see the solution for question number 10. Since summation r equal to 1 to n 5r square plus 4r minus 3. So these terms can be written as summation r equal to 1 to n 5r square plus summation r equal to 1 to n 4r minus 3 summation r equal to 1 to n 1, because they are the sum in terms of r. Here it is constant term, so you can split the summation with each term, and here 5 is the constant, this one is constant, so taken out, and we should apply the formula for summation r square. Summation r square is n into n plus 1 into 2n plus 1 upon 6 plus 4 is the constant term, so 4 is out. Now summation r is n into n plus 1 upon 2 minus 3, here constant, and summation 1 equal to n. It is a formula. Means this question is related to the formula for summation r square, summation r, and summation 1. So write these values of summation r square, summation r, and summation 1. So we get here 5 into n plus 1 into 2n plus 1 upon 6 plus 4 into n plus 1 upon 2 minus 3n. So we see that here 5 into n as it is, here n plus 1 into 2n plus 1 becomes 2n square plus 3n plus 1, plus here LCM of 6 and 2 is 6. It is here 2, so multiplying by 3 and dividing by 3 also. So denominator will be 6 and numerator here becomes constant term 12. So we should write here 12n into n plus 1 minus multiplying by 6 here and dividing by 6. So 18n means 6 into 3n upon 6. So we see that each denominator has 6. Here it is 3 into 3 into 3, that is 6, and here 6 into 3n upon 6. So taking the denominator common in all terms, so we get here entire upon 6. In the numerator 5n into 2n square plus 3n plus 1 plus 12n into n plus 1 minus 6 into 3n. Entire upon 6. Now what is common in all terms? We see that here n, and n only. It is common, so taking n common, and entire upon 6, so taken out also here. So n by 6 common in all the terms. In the bracket we write here 5 into 2n square, that is 10n square, 5 into 3n plus 15n, 5 into plus 1, that is plus 5, and here n already common, so 12 into n, 12n, 12 into plus 1 plus 12, and here minus 6 into 3n becomes, n is common, so minus 6 into 3 becomes minus 18. So we get here n by 6 into 10n square plus 15n plus 5 plus 12n plus 12 minus 18. Now to simplify all these terms in the bracket. So it is equal to n by 6 into 10n square as it is, 15n plus 12n becomes 27n, and here it is 5 plus 12, 17, and 17 minus 18 becomes minus 1. Therefore, summation r equal to 1 to n 5r square plus 4r minus 3 equals n by 6 into 10n square plus 27n minus 1. This is the answer for question number 10. Now see question number 11th. In question number 11, what is given? Find summation r equal to 1 to n r into r minus 3 into r minus 2. So this is the product of three terms in terms of r. So since summation r equal to 1 to n started here, your solution. So summation r equal to 1 to n r into r minus 3 into r minus 2. So if we multiply all these three terms, we get r cube minus 5r square plus 6r. Or you can multiply first these two terms and then this into this answer, or this into this and then multiplying by r. So the multiplying these two brackets, if we get here r square minus 5r plus 6 and then multiplying by r, we get r cube minus 5r square plus 6r. So it is equal to summation r equal to 1 to n r cube minus 5r square plus 6r. Now what should we do? Just we expand the sigma with each term. So we should expand the sigma with each term by taking constant out. So it is equal to summation r equal to 1 to n r cube minus, here it is 5r square, so this will be minus 5 into summation r equal to 1 to n r square plus, here it is 6r, so taking 6 out, 6 into summation r equal to 1 to n r. So this question is related to the three formula summation r cube, summation r square and summation r. So using this formula we get, since summation r cube is n square into n plus 1 whole square upon 4 and summation r square is n into n plus 1 into 2n plus 1 upon 6 and summation r is n into n plus 1 upon 2. Therefore, it is equal to, here no constant, so we write here only value of summation r cube n square into n plus 1 whole square upon 4 minus 5 into n plus 1 into 2n plus 1 upon 6 plus 6 into n plus 1 upon 2. Now we see that n into n plus 1 upon 2 common, here n into n plus 1 upon 2 common, n into n plus 1 upon 2 common, because 6 can be written as 2 into 3 and this 4 can be written as 2 into 2. So by taking common n into n plus 1 upon 2 from the each term, we get remaining terms from the first term n into n plus 1 upon 2 and from the second term 5 into 2n plus 1 upon 3 and from the last term here only 6 is remaining, then bracket closed. So after taking common n into n plus 1 upon 2 from the each term, we get n into n plus 1 upon 2 multiplied by n into n plus 1 upon 2 minus 5 into 2n plus 1 upon 3 plus 6. So we get these terms. After that, here it is equal to n into n plus 1 upon 2 as it is. Now multiplying, first we see that here LCM of 2 and 3 is 6. So make the equal denominators, making equal denominators, so multiplying by 3 and dividing by 3 here. So this will be 3n upon 6 and here this will be multiplying by 2 and dividing by 2. So this will be 10 into 2n plus 1 upon 6 and here multiplying and dividing by 6, we get 36 upon 6. So first we write here entire upon 6. So this is the 3n into n, that is 3n square. After multiplying and dividing by 3, this will be 3n. So 3n into n, 3n square, 3n into plus 1, 3n minus, here multiplying dividing by 2, so this will be 10. So 10 into 2n minus 20n and here minus 10 into plus 1, that is minus 10 and here plus 6 into 6 becomes 36. Entire upon 6 already written. So we get this term as n into n plus 1 upon 2 into 3n square plus 3n minus 20n minus 10 plus 36 entire upon 6. Simplifying all these terms, we get here n into n plus 1 as it is, and 3n square here, 3n minus 20n becomes minus 17n, and here it is 36 minus 10 becomes 26, entire upon 2 into 6, that is 12. So dear student, here final answer for question number 11, n into n plus 1 into 3n square minus 17n plus 26 entire upon 12. Or you can write your answer in the different form also, n upon 12 into n plus 1 into 3n square minus 17n plus 26, as you like. And one more thing, the textual answer for question number 11 is printed wrong. So this is the correct answer of the question number 11. So you should follow this answer for the correct answer. Now see question number 12. Here it has also a star mark, means textual answer of question number 12 is wrong. So what is the correct answer? I'll give you in the solution. See the question first. Find summation r equal to 1 to n, 1 square plus 2 square plus 3 square plus and so on plus r square entire upon 2r plus 1. Here 1 square plus 2 square plus 3 square plus and so on plus r square is already a sequence which is sum of square of the two numbers. Sorry, sum of square of the natural numbers. See once again your question. Find summation r equal to 1 to n, 1 square plus 2 square plus 3 square plus and so on plus r square entire upon 2r plus 1. See the solution. Since summation r equal to 1 to n, square of 1 plus square of 2 plus square of 3 plus square of 4 and so on plus square of r square entire upon 2r plus 1. Dear student, in the numerator here, sum of square of natural numbers already given. So we should write first here summation r equal to 1 to n as it is, and for the numerator we should use another symbol of the summation, or you can say sigma notation. So taking summation k equal to 1 to r k square. Summation k equal to 1 to r k square. What does it mean? This means if we put k equal to 1, we get 1 square. If we put k equal to 2, we get plus 2 square. K equal to 3 plus 3 square. K equal to 4 plus 4 square and so on. If we put k equal to r, then we get here plus r square. Means this sequence can be written in the short form as sigma notation summation k equal to 1 to r k square and entire upon 2r plus 1 as it is. So what is the value of summation k equal to 1 to r k square? So this is sum of square of the natural numbers. So we should write here the value of summation k equal to 1 to r k square in the form of r into r plus 1 into 2r plus 1 upon 6, which is a formula for sum of square of the natural numbers. Means its numerator is equal to r into r plus 1 into 2r plus 1 upon 6. This is the sum of square of natural numbers. You can say in the verbal form also if you are not understanding sigma notation. So you should write on the right hand side in the bracket here, it is sum of, since sum of square of the natural numbers is equal to summation r square, and which is equal to r into r plus 1 into 2r plus 1 upon 6 in terms of r. Then you can substitute the values here in the numerator. Which value? Same values, r into r plus 1 to r plus 1 upon 6. Entire upon 2r plus 1 as it is, no change here. So this step can be written as summation r equal to 1 to n, summation r into r plus 1 into 2r plus 1 entire upon 6 whole divided by 2r plus 1. Now we see that 2r plus 1 going by 2r plus 1, they will be cancelled out. So remaining term will be summation r equal to 1 to n, here r into r plus 1 in the numerator upon 6 here. So summation r equal to 1 to n r into r plus 1 upon 6 can be written as 1 upon 6 is constant taken out. In the bracket, summation r equal to 1 to n r square, because here r into r square, and r into plus 1 plus r. So summation r square plus summation r equal to 1 to n. Now substituting the formula values, so summation r square is n into n plus 1 into 2n plus 1 upon 6, and summation r is n into n plus 1 upon 2. So whole step can be written as 1 by 6 multiplied by n into n plus 1 into 2n plus 1 upon 6, which is value of summation r equal to 1 to n r square, plus summation r equal to 1 to n r is n into n plus 1 upon 2. Now 1 by 6 as it is, here it is n plus 1 upon 2 and n plus 1 upon 2 common, because 6 can be written as 2 into 3. 6 can be written as 2 into 3. So clearly here n plus 1 upon 2 common. So remaining term will be 2n plus 1 upon 3. So this is 2n plus 1 upon 3 here, because n plus 1 upon 2 common from both the terms. So 2n plus 1 upon 3 remaining from the first term here, and plus 1 remaining from the second term. Now its simplest form is here n plus 1 upon 2, n plus 1 upon 2 multiplied by 1 by 6. So it can be written as n into n plus 1 upon 12. And here 3 1s are 3, that is 2n plus 1 plus 3 upon 3. 2n plus 1 plus 3 upon 3. Now it is equal to n into n plus 1 into 2n plus 4 upon 12 into 3. Here it is 12 into 3. But we see that here 2 is common, because 2n plus 4. So here 4 can be written as 2 into 2. So 2 is common from this bracket. So taking common, we get n into n plus 1 into n plus 2 into 2. Taking 2 common from the last bracket, so we get here n plus 2 into 2 upon 12 into 3. And here it is 2 6 is 12. This will be divided. So 6 into 3 becomes 18 here. Therefore, the final answer of question number 12 is n into n plus 1 into n plus 2 upon 18. So this is the corrected answer, because it is given in the textbook wrong, or you can say in the textbook printing mistakes. So correct answer of question number 12 is n into n plus 1 into n plus 2 upon 18. Now see once again explanation of this question. Here find summation r equal to 1 to n square of 1 plus square of 2 plus square of 3 plus and so on plus square of r upon 2r plus 1. So first we write the given summation here, since summation r equal to 1 to n square of 1 plus square of 2 plus square of 3 plus square of and so on plus r square entire upon 2r plus 1. So we see that here it is sum of square of the natural numbers. So we should write as a sigma notation form. So using the another letter, because r equal to 1 to n already here it is given. So we use here summation k equal to 1 to r k square entire upon 2r plus 1 as it is. So summation k equal to 1 to r k square becomes r into r plus 1 into 2r plus 1 upon 6. If we write here, compare these two. If we write here summation r equal to 1 to n r square, summation r equal to 1 to n r square. So we write this answer in terms of n plus 1 to n plus 1 upon 6. And if it is summation k equal to 1 to r and k square, so we write its answer in terms of r into r plus 1 into 2r plus 1 upon 6. So this step can be written as summation r equal to 1 to n. This is the main summation, and then here bracket summation k square in terms of r into r plus 1 into 2r plus 1 upon 6 entire upon 2r plus 1 as it is. No problem here. Now here 2r plus 1 2r plus 1 will be cancelled because they are same. So remaining term here r into r plus 1 upon 6. So we write here with this sigma summation r equal to 1 to n r into r plus 1 upon 6. Now, you know very well this 6 is constant, so taken out 1 by 6. Then it can be written as summation r square plus summation r equal to 1 to n r. So using these two formulas for summation r square and summation r. Once again, if you don't know the formula in terms of summation or sigma notations for geometric progression, so you should click on the link which is given in the description box of the same video. You will get formula list. You can check the description of the same video. At last, a link is provided where it is given that formula list, and click on that link. You will get formula. So it is 1 by 6 into n plus 1 to n plus 1 upon 6 plus n plus 1 upon 2. And here 6 can be written as 2 into 3. So taking n plus 1 upon 2 common from these two terms, so we get here 2n plus 1 upon 3 plus 1. After that, it is equal to n into n plus 1 upon 6 into 2, that is 12, and here 3 ones are 3, so this will be 2n plus 1 plus 3 entire upon 3. Now it can be written as n into n plus 1 into 2n plus 4 upon 12 into 3, but 2 is common in the last bracket, so taking 2 common, the remaining term will be n plus 2. So whole step is n into n plus 1 into n plus 2 into 2 upon 12 into 3, and 12 goes by 2, so 2 6 are 12, 6 into 3 becomes 18. So its final answer is n into n plus 1 into n plus 2 upon 18. So dear student, its textual answer is wrong. This is the correct answer for question number 12. So for the remaining question of the same exercise, that is miscellaneous exercise 2, and for the remaining chapters and for the questions for competitive exams, watch my coming videos. Thank you so much.